Here's what I want to do with you today. On Friday, we put two triangles on a graph and said, are they rigid motions, which means one was congruent to the other, and they were by side, side, side. Here's what I want to do today. I still want to put a triangle on a graph, but here's the catch. No number coordinates. So 2, 3 is going to change into 0, 2b. All right, we're using variable coordinates now. All right. Tomorrow we'll use them in distance and midpoint. Today what I want to do though is just set it up appropriately and correctly on a graph. All right. Just look at my first example. I'll go over the little tips above as we're doing it. Just let me look at my first example. Here's what I need from you. On the graph, I need a right triangle. So it's got to have a right angle. The legs, what do I mean by the legs of a right triangle? The two sides that form my right angle. All right. Those two sides I'm going to call AC and AB. So just looking at those two right now, anybody know where the right angle is going to be? A. Okay, so let me just, you don't have to draw this. We'll put it on the graph in a second. So there's A, and then B and C could be anywhere as long as A is the right angle. All right. AC has to be 2A units long. Not 5, not 6, 2A units long.
Yes.
No. We're done. I hate all of you. I really do. I do. I really hate all of you. All right. So one leg has to be 2A, and the other leg's got to be 2B. But I have to set it up on the XY axes, and each of these vertices has to have coordinates. All right, so that this length is 2A, this length is 2B. All right, couple tips before we start. First is, when you're putting a triangle on the graph, try to have one of the vertices as the origin. Okay, try to have one of the vertices as the, you can use 0, 0. Those are the only numbers you can use though. All right, everything else has to be in terms of variables. Place at least one of the sides on the x-axis. Let's start doing this now. So I'm going to place A right here at the origin. 0, 0. Place at least one of the sides of the triangles on an axis. All right, so if I put, let's say, I'm just going to copy my diagram over here. Let's say I put C somewhere on the x-axis. And how long does AC have to be again? 2A units long. So can you guess the coordinates of C then? Well, first thing is it's on the x-axis. So what's got to be the y coordinate if it's on the x-axis? Any point on the x-axis will have a y coordinate of what? Okay. Now let's think about this. How long does it have to be from A to C? 2A. So guess what my x coordinate is going to be? 2A. So this coordinate right here will be 2A, 0. All right, what about my other leg, AB? Well, maybe it might be a good idea to put it where? Not only on the y-axis, but on the positive side of the y-axis. All right, and could you put it down here? Sure, you could, but I really don't want to start involving the negative coordinates. So I'll put it right up somewhere on the y-axis, point B. You should at least know what's the x-coordinate of anything on the y-axis. 0. And then in this case, what's going to be my y-coordinate if I have to have a length of 2b? 2b. And there is a nice right triangle. Now, is that the only way I could have designed it? No. You know, I could flip it over here, so point C is over on this part of the x-axis. That goes to my third tip, is try to keep everything in the first quadrant. Anybody know why I like to keep everything in the first quadrant? X's and Y's are all positive. Could I have put this in quadrant 2, 3, or 4? Absolutely, I could have. But then I need to worry about what coordinate, X, Y, which one's negative. All right, and I don't want to do that. Everything's positive in the first, so let's keep it that way. All good there with the right triangle, because there's other types of triangles I'm going to have to put on a graph. Questions? All right, next one I'm going to ask you to do. Isosceles. Ooh, isosceles triangle. Before I start, vocabulary term, base. Anybody remember what we referred to as the base? Don't tell me the bottom. The one that's not parallel. The one that's not congruent to the other two sides, the outcast side, yes. Okay? So FG's got to be on there. H will be on there. That base has to be 2A units long. So suggestions on maybe where should I start by putting that base? On the x-axis, right? Okay? So I'll put F. You could put G there as well. We'll call that 0, 0. And then what point should G be? It's got to be 2A units long. 2A, comma, 0. All right, now we got a little work to do. Now we got to put H somewhere. And wherever you put H, it's got to still be an isosceles triangle. We like to keep everything in the first quadrant, right? Okay, everyone agree? Keep everything in the first quadrant. All right, let's see. I could put H there. I could put H up here. Is it really going to matter how high I put H? Is it always going to be isosceles? No matter how high I put H. Depends where I put it on the x-axis. All right? If this is going to be isosceles, these two sides always need to be congruent. So where should I be putting point H in terms of F and G? Directly where? In the middle. Now, when I say in the middle, let's not pull one of these and put H right there. Okay, let's not pull one of those. But yes, H definitely has to go halfway in between F and G. So what will be the x-coordinate of H? From here to here is 2A. I'm going directly in the middle, so what's my x-coordinate? A? Now, do you see what I was talking about? It doesn't matter how high or how low on the y-axis it goes. So what am I trying to show you here? This y-coordinate does not matter. We can put a happy face there if we wanted to. All right, but we're sticking with variable coordinates. So what you can go B, you can go 8A, you can go, nah, I probably would stay away from A, but 8C, 12D, it doesn't matter. Everyone agree? It doesn't matter where on the y-axis point H is, as long as it's halfway in between F and G. All right, so I'll put A, 2B, you want A, B, whatever your favorite letter is. But do you understand, do you see why, guys, doesn't matter where on the y-axis I go? Everyone agree? Yes, no, maybe? Okay, we're not done yet. What course are we in? Okay, let's do it a different way. Let's do this a different way, where we're not involving the origin as a vertice. Can we get that done? So you have plenty of room there to draw another diagram right to the right. No, I want to stay on this problem right here. We're staying on this problem. I just want to draw this triangle differently. Without using, bless you, without using the origin as a vertice. Here's a little hint of what I'm looking for. Can we do that? Can we move this here now? So here is still F, G, but what would my new coordinates have to be now? Because remember, it's still got to be a length of 2A. Still got to be a length of 2A. And I kind of want the y-axis right in the middle, too. All right, Roman, what do you got for me? Negative A, comma, 0. So right now, he's giving me what's the length of F to the origin right now? No, 1. Just A units, right? And it's got to have a length of 2. So Roman, where are you going to put point G? Positive A, 0. Does everyone see how that's got a length of 2A? Take a look. That's A. And this distance is A. Add them up. It's got a distance of 2A. All right, and then what about this point on the y-axis? It's definitely got an x-coordinate of what? 0, and then whatever you need. All right, whatever you need, because we discussed it doesn't matter how high you go on the y-axis, just as long as that x-coordinate's halfway in between. All good. Questions designing your own, because I'm going to design one for you now. You just have to tell me what the missing coordinates are based on where I put the triangle. And I need my notes for this because I cannot see a darn thing on there. Okay, we got an isosceles triangle XYZ. Help me find the, I got to give you some other information because you have no idea what the congruent sides are here. All right, so this is isosceles triangle with XY congruent to YZ. Okay, those are the two congruent sides. All right, so I filled in the x coordinate of z for you. You got to fill in x, y, and the y coordinate of z. All right, I'll start with the easy one first, which is point x. Point x. Come on now. 7, point x. Point x, x, x. Point x. 0, 0. Everyone all good there? What about point y now? Halfway in between if it's isosceles. Here you go, 18. What's the x coordinate on y? Half A. So we can write that one of two ways. You guys can write 1/2 A, or you could write it as A over 2. Both mean the same thing. Whatever floats your boat. And the y coordinate? Whatever you want, right? B. We'll go with B. And then how about coordinate z is A, comma, it's on the x-axis. It's on the x-axis. Let's not get fancy. Here you go, 16, y coordinate. Y coordinate of z, 0. It's on the x-axis. Questions there? All right, next one. The two congruent sides are AB congruent to BC. And this has to be an isosceles right triangle. So the two legs have to be congruent, AB and BC. I didn't even need to give you the two sides, but. I'll start with coordinate B, and then we'll move to C and A. Okay, coordinate B, let's just get this done. Coordinate B, here you go, 28, coordinate B, 0, 0. How about coordinate C now? Coordinate C, I gave you what? A, comma, here we go, 3. A, 0. Okay, now, here's the big one. Coordinate A, got to be isosceles. Got to be isosceles, so the y coordinate's going to matter here. 8, 0A. Okay, that makes one leg a length of A, the second leg a length of A, making it isosceles. Any questions from you guys? Because the next one's the toughest one we're going to do here today. First time we've talked about this, the equilateral triangle. Equilateral. All sides congruent. Can we just get through W right now as a class here? W. 0, 0. Okay. And And point Z now. Ready? Here we go. Point Z. Well, X coordinate should be no problem. X coordinate's going to be, okay. Now the Y coordinate, because it's equilateral, it's going to matter. I just can't put 2Z or whatever letter is my favorite up there. Does everybody see why? Because if let's say I move Z up, now I'm making these two sides longer, and they won't match the third side. It won't be equilateral anymore. So yes, the Y coordinate will matter now. We all in agreement? Okay, how the heck do I find that Y coordinate? Get ready to bust out your algebra skills here. Okay? Does everybody agree? The distance of this line that I'm drawing down is the Y coordinate. However high I go here, that's going to be the Y coordinate. So whatever the length of this segment I just drew in will be my Y coordinate. Everyone agree? Over how many, up how many, right? Over and up, that's your Y coordinate. Yes? We're all good there. All right, so I'm just going to call this Y for my Y coordinate. All right? And that distance I'll give you is perpendicular, because that'll be key here in a second. Do you see how I formed two right triangles? Could you find the other two sides of those two right of one? Let's take one of them here. I'll take this one on the right. Doesn't matter which one you take, they're both the same. Can you find the other two legs? Can you find the length of the other two legs before we get going? It's equilateral, right? What's the length of this side here? 2a, so any other side will also be? It's equilateral, right? This length is 0 to 2a is 2a, so this tells me this side is 2a, and because it's equilateral, all sides are 2a. Ooh, how about the length of this one down here? Anybody know if I know two sides of a right triangle and I'm trying to find the third, what I can use to find it? Pythagorean Theorem. Ready to go. Here's the general form of a squared b squared equals c squared. A and b are referring to the legs. Stay with me. Two legs. Name a leg. A squared plus, well, what do I have labeled as the other leg? Y squared. We got to solve for that because that's my Y coordinate. Equal to hypotenuse. What's the hypotenuse? Hey, everybody, no, no, no. If you have that on your paper, that's a no right now. What's being squared? If I write that, what's being squared? Just A. What do you want squared? The hypotenuse of 2a, so I have to put this parentheses, so I'm showing I'm squaring the whole thing. If you leave it without parentheses, you're just showing me you're squaring the A. And remember, we're solving for what here? Y, this distance here, which give me that final Y coordinate. All right, let's go to work. A squared plus Y squared equals, anybody? 2a all squared? 2a times 2a. Oh boy. 2a times 2a. 4a squared. A little honors level here, I know. All right, your next move? Yeah, get the y by itself, right? Subtract over a squared. What do I have here now on the right-hand side? 4a squared minus a squared. 3a squared. Got to get that y value. Got to get that y value. How do I get rid of the square? That's the last thing left. Square root. All right, let's talk here, algebra studs. Out of everything that's in here, what can you take the square root of? Can you take the square root of 3? Nope. Can you take the square root of a squared? What is the square root of a squared? Okay, a And then what could I not take the square root of? 3. So that stays underneath the radical. And as cruddy as that looks, there's your y coordinate. A radical 3. One more time. Whoa, before I let you loose, one last time here. To find that y, the x coordinate's easy. It's halfway in between. To find the y coordinate, I drew this perpendicular line down, which represents the y coordinate. Splits this side in half, and since it's equilateral, whatever a side length is, it matches the hypotenuse. The only thing I worry about is make sure you put that in parentheses before you square it. All right, this is not the only time you're going to see equilateral. You'll see it in a couple minutes when you start the homework. Questions? All right, look at this. I know this is new, but yeah, let's start the assignment for tonight now, please.